All right. So, Mr. Walker was convinced that Julia, you, Katie, and were the sweetest girls in the whole wide world. Letting you know, yesterday these mean girls asked their first period teacher to pass us to the bathroom, but says by past the marks meant the safety security specialist to the bathroom parking lot where they still uh, they were still pretty mad at Mr. Walker because they found out they had to final examination. Julia brought drill, Maya brought trusty decometer from Home Depot, 14 right? And Katie brought a diver. We're going to act as lookouts. Julia drilled a tiny hole to the gas tank, and Mr. Walker should be right. 4 girls watched sleepless gas drain down the tank. Maya used her leakometer to readings at the rate at which the gas drained up every minute, while Katie recorded data in the diary. Erin was so distracted by her cravings for LaCroix that she didn't even notice Mr. Flick running out to Starbucks for caramel macchiato and failed to sound the alarm. Mr. Flick captured the whole culprits and confiscated the diary, which she turned over to the very sad Mr. Walker. Being the true calculus geek that he is, Mr. Walker used the data these girls managed to record before being caught to make this calculus problem.
Someone had put the first time to write these.
Yes, they did.
Someone got paid way too much to write this monstrosities. Okay.
So here we have our charts. At time 0, the rate of gas is leaking is 3.5. After 1 minute, so we have a rate of 3 gallons per minute. 2 minutes, 2.6. 3 minutes, 2.3. 4 minutes, 2.1 gas. So estimating from the table, what is the maximum amount of gas that could have leaked in the first minute? 3.5 gallons per minute. Maximum it could be is a straight line of 3.5 the entire time. So after 1 minute, that'd be 3.5 gallons. What's the minimum? Yeah. Well, after 1 minute, it's going down to 3. So what they're saying is that at the beginning, right at 0, the rate was 3.5. But once they got to 1 minute, the rate was 3. So the possibility is it could have jumped down to 3 and stayed at 3, but the rest of it. Yeah, like 3. The amount of gas that actually leaks must be between 3 to 3.5 gallons. If you use either the max or min's true values, what is the most you can be wrong? Yeah, 0.5. Yeah, plus or minus. If you use the actual max and then it was the min, you'd be off by 0.5. Then it was the actual max, you'd be off by 0.5. If you use a midpoint between the two, then yeah, you'd be off by plus or minus. Max possible. What may be a reasonable way to make the estimate of the gas that actually leaked out during the first minute? Like we just said, kind of average. Okay, which would be about 3.25 gallons. And if we, like we just said, if we use that as an estimate, we would be at most, the maximum error would be 0.25 gallons. Right. What about the second minute? The second minute, the max amount that could have leaked out would have been from, again, from 1 to 2, the max would have been 3, the minimum would have been 2.6. So find an upper bound on the total amount of gas that could have leaked for the entire interval shown your setup. Right? So the upper bound, which means what is the maximum that could occur over the entire time, the first 4 minutes. Okay, so So from minute 0 to 1, the first minute, the max would have been 3.5. So for the first minute, the max would have been 3.5. For the second minute, the max would have been 3. Third minute, the max would have been what? 0.6. And for the last is the max would have been 2.3. What does that add to? What about the 2.1? Well, that's the minimum that could have been over the last one. 4 minutes, 4 amounts. So, let's see here. 6.5, 9.1, 11.4 gallons total max. Alright, what's now find the lower bound. Now the lower bound would be after the first minute it would have just been 3, and then the second minute it would have been 2.6, and the third minute the minimum value would be 2.3, and the last minute it would have been 2.1. So that would give you 3, 5.6, 7.9. The total amount is the total form would be somewhere between 10 gallons and 11.4 gallons. Now, how far off for the true value could either of these be? Well, what's the difference between plus or minus, depending on which one you went? Now, what's the average between the two? 7 gallons. Which that would make the maximum error half of the other one, which would be 0.7 plus or minus. So, part 2, estimating from a graph, plot the table to sketch the smooth curve from the points, draw the rectangle. Okay, we'll just spot the points first. So the first was what, 3.5 gallons? That's the red. So 3.5 gallons at 0, at 1 it was 3, at 2 it was 2.6, and then 3 was 2.3, and then 4 was 2.1. And see, it does have kind of a curve here. That's part 1. Part 2, draw rectangles that has the base from 0 to 1 on the x-axis and a height of 3.5. Okay, so. And we'll shade that with a blue color pencil. Not more transparent. What is the area of that rectangle? 3.5, 3.5. Does this quantity represent in terms of real world context? Think about units. Maximum. Yeah, that's 3.5 gallons per minute, which was the max amount for the first minute. So now draw a rectangle over each 1 minute interval such that the height represents the maximum rate. So we're going to do that, and we're going to use this rectangle, that rectangle, and that rectangle. So the initial would represent the mass amount of gas that could have leaked out in that minute. Find the area of each of these rectangles and calculate the sum. We kind of already did that, right? What do we? Yeah, that's 3.5 times 1 plus 3 times 1 plus 1 plus 2.3 times 1, which gives me that 11.4 gallons. Seems familiar? How does this answer compare to the answer on question 6 in part 1? It's the same. What does this sum represent within the problem? Max gas that could leak out over entire max gas could have leaked out over the entire interval. Let's do red, so I'm going to use red. Do the same thing where make rectangles using a red pencil. You have to. I have red. So you get red. Here. Seven. Red one, what? 10 gallons, because that would be 3 times 1 plus 2.6 times 1 plus 2.3 times 1 plus 2.1 times 1. So this represents minimum amount of gas. Usually so just bonus. That could lead out over the time. Quantities represents what we call the left-hand Riemann sums, or LHS, and the other, the right-hand Riemann sum, RHS. Which is which, and why do you think? The max will be what? The left or right? Well, all the max values are on the left or right side of the rectangle. Left side. And the minimums would here be what? The right-hand Riemann sums. And that only works for this instance. Okay, we could have a different function. Okay, where the left would be the max, or the left would be the min, and the right would be the max. But in this case, if I wanted the max values, I would use the left-hand Riemann sum. The min values, I use them. Now, the idea here is looking at the graph, could I have actually found the true volume or amount that was lost just based, So we use these rectangles to make an estimation, right? Is there a way, ask this, I'm not looking forward to notes, so probably ask this later on. Is there a way I can make a better estimation? Oh, this is one of the. What if I use more rectangles? Okay, so could I have used as many rectangles to where it basically covered the curve itself? So we would say the limit to the number of rectangles would approach infinity. As the limit to the number of rectangles approaching infinity, the closer it would be to getting your true actual volume or amount. Fortunately for you guys, you don't have to actually calculate this stuff. If this was taught out of a traditional calc book, we would have started with this, and you would have hated it. Understood it.
Why is it that on the right hand, the left hand side, it's the max when we went to the right of the graph?
On the left side, that's the max value of the rectangle. This is the left side, this is the right side, right?
Yeah.
So the left side is the max value, the right side has the smaller. Easier way to think of it is if I look at the chart here, which number is bigger, left or right?
Okay.
So if it, like I said, if it went the other way around, then the right hand, if this went like from 2.1 up to 3.5, then the right hand would be next. Just depends on the order of the numbers. So left hand and right hand rhyming sums are not always guaranteed to be not and min respectively. It just this one happened to be this one backwards. So now the average two sums, we already found the average two sums was 10.7 gallons. Okay. So part three, error for right and left hand sums. For the function to the right, draw the rectangles forming the left-hand sum shaded blue, calculate the left-hand sum. Right. So left-hand sum, now we're going to be using what they give us. So we're using a base of 2, and here we have a height of 8. So 2 times 8 would be 16. Now, by the way, they say delta t, that is it's always your length of your base. Okay, whatever delta x or delta t is, that is your base. Delta just means change it. Here we have 7 times 2, which is 14. Sure, just do that. I didn't scroll down. So that is 14. And then we have 5 times 2? That's 10. So that adds up to 40. And there's no units, so just 40 units. Alright, let's just draw in red. Right, sums. So here we have 7 times 2, which is 14. And we have 5 times 2, which is 10. And we have 2 times 2, which is 4. That adds up to 28. So which estimate is an overestimate and which is an underestimate? Well, which one have rectangles going above the graph? Overestimate would be left-hand sums. Underestimate would be the right-hand sums. So again, this should be hopefully pretty simple. Right? So we do the same thing for the next set of questions, but use 0.5. So in this case, we are going to do my left hand, again, left hand blue. So that is 1 times 0.5. So left hand sums is 1 times 0.5. Plus, we have 4 times 0.5. And then we have 6 times 0.5. Which, now, do you notice that since they're all being multiplied by 0.5, could we just add them up and then multiply by 0.5 again? Mm-hmm. Yeah. So 0.5 times 1 plus 4 plus 6 gives you half of 11 or 5.5. You don't know what units are, so it's fine. So right hand sums, in this case, we do a right sum, so that's 4 times 0.5, 6 times 0.5, and 7 times 0.5. So again, 0.5 times 4 plus 6 plus 7 is 1/2 of 17, which is 8.5. Well, now in this case, the left-hand sum will be the underestimate, and the right-hand sum will be the overestimate. The process as to when you will get an underestimate or an overestimate, depending on which type of sum used, cavity, increase, decreasing, positive, negative. We'll actually talk about this on the next page anyway. Just think about it. When will we have an overestimate? When will we have an underestimate? So, next page. Trapezoid and midpoint rule. So showing this graph of the velocity of an object over 50-second time interval, we want to estimate the distance the object traveled over the first 40 seconds using right and left hand. Along the different approximation techniques, midpoint and trapezoid rules, be sure to use the table in conjunction with the graph. So, part 1 says use the left-hand sum method with the 4 partitions that are given. So here we're going by tens. Okay, we're going by tens. Now, this chart is not going by tens. This chart is going by fives. So when we go by tens, we're looking at these values only. Okay. Now, we don't need the graph per se, we just need the chart. If I want the left-hand sums, I'm going to use the first or second number. Which one? First, because it's on the left. So here, I'm going to have 0 times 10 plus for the first interval. Okay, the second interval, I use 20 times 10 plus 55 times 10 plus 78 times 10. That would just be 10 times 0 plus 20 plus 55 plus 78, and we can just put that in a calculator. So 20 plus 55 plus 78 times 10 gives you 1,530. And this is in feet. Oh, it's because it says right feet. All right. Do the same thing with the right-hand sums. Now, in this case, we're going to use the right numbers. So that is going to be 10 times 20 plus 55 plus 78 plus 75. So really, we can add 75 to this, and then multiply that by 10, which gives me 2,280. Now, using the midpoint sum, what we're going to do for each of these is just use the middle value, 2. So that breaks these. We're still going to use the distances 10, the change in time is 10. Okay, but we're going to be using these 4 values instead. So that'll be 12, 30, 70, and 81. So 10 times 12 plus 30 plus So 70, 81, 1, which give you 181 plus 12, 193, so 1930 feet. And it says use trapezoidal subs. Now, trapezoidal, you remember the area of trapezoids? You remember area of trapezoids? Area of trapezoids is 1/2 height times base 1 plus base 2. Okay, now let's think through this so we can save ourselves a lot of time. Okay. I can rearrange this as to the height times 1/2 of base 1 plus base 2. All right. What is my height on every single one of these? The change in the base the entire time? The height of every single one of these is 10. Okay, because that's the distance between the two bases. The two sides are my bases. It's just a side of this trapezoid. Okay. The bases would be both the left and right hands. So if I do 1/2, the left and right hand values, what am I actually finding? The average of the left and right hand. So could it just take the average of the left and right hand sums? Yes. The trapezoid rule is equal, so trapezoid rule is equal to the average of left hand sums and right hand sums. So if you do your left and right hand sums and just average them together, it'll be fine. So let's see what those are. It was 150, 1530 and 2280. So 1530 plus 2280. Oh, what we just did. I would kind of already answered part 5 because I didn't want to waste your time. So let's just yeah, we can skip question 5. 1530 this 1530 plus 2280 divided by 2. Correct. Divided by 2. 1905. So usually the trapezoid rule is going to be your best estimate. Okay, the midpoint rule is also a really good estimate because you can see how close they are together. Okay, but most often the trapezoid rule is going to be best.
Is there going to be like a time on the test or something where we actually have to plug in for that?
The trapezoid will always follow the average of it, always. So if you want to do that, go right ahead. Okay. But no matter what, it's just algebra alone, it's equal to the average. All right. So looking at the diagram. Next page, last page. You're done after this. We're going to sketch just the left-hand sums. So what kind of function, by the way, what kind of function is the first function? This is increasing, and it is concave up, right? So let's see if I'm using left-hand sums. That's interesting. All right. Definitely not interesting. All right. This is increasing and concave down. Left-hand sum. Sum. Still a here we have decreasing function, concave up. Now my left-hand sum is above. So here we have no risk.
Wait, sorry. Because we didn't have her sheets, so she's. Sorry on that.
I agree. Hey, yes, sit.
Okay.
And she Yes, they had touch last year. I still do change rate form.
Yeah.
But
There's
It's fine.
It's
Yeah. And like every time we set it up. I mean, and she's.
Yeah. Okay, yeah, no, it's as long as you're willing to do that.
Sure. All right, so here we have decreasing. And concave down. Decreasing, concave down. Decreasing, down, left hand sum also overestimate. So looking at this based on the graphs, when will the left hand sum have an overestimate?
What is the decrease?
A decrease. And it's gonna have an underestimate when it's increasing. All right. What about right hand sums? Do you think that'll be backwards?
Yeah.
Yeah. Right hand sums, here we have an increasing function, overestimates, overestimate, overestimate. Same with concave up, concave down, doesn't make a difference. And then now that it is decreasing, underestimate. Concave up and concave down. What about midpoint? So for the midpoint, what we're going to do is we have point here. Point here. I'll be halfway between the 2 points. Point here. Now, would you say that is an over or under estimate? Pretty good estimate, but we say over or under. I would say underestimate here. Because there's more missing, especially right here. There's more missing area than everywhere else. Okay. All right, so it's concave up. Let's say concave down. I find a good midpoint here. Sure, zoom in that. So up here. Here. So I would definitely say in this case, I would have an overestimate. It's very overestimate. So it really looks like for midpoint sum, it's going to be an overestimate if it's concave down, underestimate. Right. So let's do something here, midpoint. Point. And midpoint. So we have functions down here. It's an overestimate when it is increasing. Okay, an underestimate when it's decreasing. That was well, it's overestimate when it is decreasing, underestimate when it is increasing. Okay. Here is an overestimate when it is increasing, and underestimate when it's decreasing. So concave up and concave down have nothing to do with it. For the midpoint, we said is overestimate when it is concave down. Concave down, underestimate when it is concave up. Increasing and decreasing have nothing to do with it. All right, let's look at trapezoid. trapezoid, we're using just average of lettuce, so we're basically just be making trapezoids here. So in this case, I think that would be an overestimate for its concave up. Concave down, I would say it's an underestimate. Line is going to be under the curve. Here it's above the curve. Let's see this true. The next one is concave up. A little more, isn't just a bit above the line. Concave down. Just a bit below the line. Still a pretty good estimate, but yeah. Looks like concave up is where it's overestimate. Down. Increasing, decreasing. That's it. Today. So I do not have any homework for you in this case because there's nothing on there that has and you didn't do this until we do what we're doing the next day. Big five, we will have homework on the limit definition of an interval. So we just have 2 days left. A 5-day tips, and then we'll study tests.
Let's show you mine.
Where's Gavin today?
I don't know. Might be sick. A lot of get sick.
Yeah, I can understand that happens. All right. So yeah, Gavin, Boston, Ava, yeah, all.
Yeah, Boston has the flu.
Yeah, I might have had the flu too. So apparently there's several versions of that one going on.